Welcome back to LocalM Tuts. I'm Nilay Parikh. This is lesson 9 of 16, A2A with Google ADK. Last time we built an orchestrator with Microsoft Agent Framework that route the task to remote A2A agent. If you're watching this as a standalone video, find the complete course playlist in link below in the description. Here is what you find: all the code for the lesson, the links of GitHub repository, and the interactive page is in the description. Clone the repo, open the lesson folder, and follow along. The loan validation agent using Key2 thinking via the LiteLlm. The magic is actually in just one method. It's called to_A2A. It auto-generates the agent card, create the executor, and start the server. One line replaces everything from lesson 6. Compare this to lesson 6, where you wrote the agent card JSON, agent executor class, and server startup manually. ADK does all three in simple function call. It also supports multi-agent pattern, sequential parallel, and the loop agent natively. Let's see this in action. Install the dependency, configure the credentials, start the server on port 10,002, run the client, and watch how A2A does everything. Agent card, executor, server, just in one line. Pause the video and try it yourself. Lesson 9, practical implementation for Google ADK. As we saw, it's just a one method, does all the magic. To_A2A, one-liner that converts any ADK agent into the standard A2A server. And this is what we are doing. We are just literally calling A2A. And the same pattern as we discussed in the Microsoft Agentic Framework, orchestrator, which does the orchestration, and we are using Google ADK components. And the same logic, same approach, but with the Google SDK and the client. Client always use the A2A because one of the key aspect that I want to prove is A2A interoperability work irrespective of server. So server and orchestrator implementation using the SDK, but the client implementation using A2A. Of course, you can do the client implementation using Google SDK as well, but it demonstrates like how interoperability available with the A2A as well. So let's see the same loan data, the same validation rule, and we are in the same SRC. So let's just go ahead and run the server and let's see what happens. Python and client, and let's see if server is up and running by now. It's coming to, there we go. It's on. It's running now. Some of the experimental warning, I haven't suppressed it. And now let's run the client. Again, I said some of the experimental conditions, some of the experimental flags I haven't turned off. But it is validating perfectly. See, so it worked well. These are just warnings coming from experimental features. I should have done slightly better, but yeah, it's not an error. It's not fake. And if we go back on our 9, it does generate the same approval and rejections. So just stopping everything here. And job done. It has dropped all three. Perfect. So now let's wrap it up with a very simple cover. Orchestrator does all magic about how to orchestrate using different sessions, agent, and it also uses the LiteLlms. By the way, Google ADK may be hard to port on Azure or anything. It's generally very good with the Vertex AI or Google Cloud dependency, but if you're using Azure or any other LLM endpoints, then you might need a LiteLlm adapter, which is not a bad idea. It's a good thing. It's available in Google ADK itself, and it helps you to port to any other model. And the client, simple A2A client, and the server, simple Azure, simple Google SDK to A2A. That's it. You have built the simplest A2A integration in the course, a fully compliant server in about 15 clients. The orchestrator from lesson 8 can already call this agent without any changes. Thanks for watching this lesson on LocalM Tuts. In the next session, we will combine A2A along with the LangGraph, building React agent that uses MCP tools A2A for agent communication. You can find the next video link in the A2A protocol playlist in description. See you there.